Hello and welcome to Chapter 5, Section 1, where today we're going to talk about exploring what makes triangles congruent. If two triangles are congruent, then the corresponding parts of the triangles are congruent. Corresponding parts of congruent triangles are congruent. So we shorten this to CPCTC. The converse of this is if all the corresponding parts of two triangles are congruent, then the triangles are congruent. So if every single angle and line are the same on both triangles, then the two triangles are congruent. So we're going to play with this and use these in proofs. A, on this first page of Chapter 5, Section 1, gives you 3 angles to trace and 3 lengths of lines. Now, you can only make one triangle with those parts. It asks you to do it twice for triangle ABC and triangle DEF. If you have 3 lengths of lines and you're asked to put those together, there's only one triangle that will make. So B asks us, how can we prove the triangles are congruent? You can find the rigid motions that maps one triangle onto the other. So if you are given an angle and a line measurement and another angle measurement, you could actually find the rigid motions that maps A, B, C onto DEF. C is a reflection and a translation. D is a counterclockwise rotation because line AB is congruent to line DE. So next up we're going to talk about how to decide if triangles are congruent by comparing corresponding parts. So here's a biconditional statement. A biconditional statement is P is true if and only if Q. And they write that, the shorthand for that is if and only if. So it's if with a double F. Two triangles are congruent if and only if corresponding pairs of sides and corresponding pairs of angles are congruent. So ABC and DEF are congruent if and only if the sides are congruent and the angles are congruent. So first they give you triangle GHJ and triangle KLM. They give you all 3 sides, and they give you all 3 angles. And when you rotate GHJ, rotate it and translate it to the right, each side and each angle will line up. And because you can do a rigid series of motions that maps one exactly onto the other, you know that these two are congruent. So understanding this, try B now. Pause and come back when you're done. When triangle ABC rotates and translates right, line BC is not congruent to line EF, 8,5 and 8,4. Therefore, triangle ABC is not congruent to triangle DEF. A contrapositive means if it's not P, then it cannot be Q. The contrapositive of a true statement is always true. And that's what we just proved here. If not all of the sides or not all of the angles are equal, then the triangles are not congruent. So pause here to do reflection number 3 and your turn numbers 4 and 5. Come back when you're done. Number 3 is yes. If the corresponding parts of 2 figures are not congruent, then the figures are not congruent. Number 4 has us comparing RST and UVW. The answer is yes, because all 6 of the corresponding parts of congruent triangles are congruent, therefore the 2 triangles are congruent. In number 5, the answer is no, because some of the corresponding parts are not congruent. Next, we're going to look at the properties of congruent triangles. The triangle sum theorem states that the sum of the measures of all 3 angles of a triangle equals 180 degrees. So our question here is to find the value of the variable that results in congruent triangles. So knowing that these 2 triangles are congruent because 3 sides are congruent and 2 of the 3 angles are congruent, we know that angle P is 5x plus 30 degrees. We want to find the value of the variable that makes this triangle and this triangle congruent. So we know that if we said 180 minus 55 minus 45 will give us this angle. So we know that angle J equals angle M, which is 55. We know that angle K equals angle N equals 45. We know that 55 plus 45 plus whatever this third angle is going to equal 180 degrees. This is 100 plus this equals 180. So if we added 100 plus 30 and subtracted it from 180, we end up with 5x equals 50, so our x equals 10. 10 is the value of the variable that results in congruent triangles. So pause here, try B, and come back when you're done. With B, we have triangle ABC and triangle DEF that we have rotated 180 degrees and translated right. So our correspondence here, line AB equals line DE equals 36, and line BC plus line line BC equals line EF, which equals 30. Line AC equals line DF equals 50. So we know that 2y plus 20 has to equal 36. And I subtract 20 from both sides, and 2y equals 16, so y equals 8. Pause here to do the reflection number 6 and your turn number 7 and 8. Come back when you're done. Number 6 is no. All 3 angles need to be congruent. 18 degrees can be the same, but if the second is 84, then the third can't be 76 because that would equal more than 180. With number 7, angle F equals angle C, which equals 112. Angle G equals angle D, which equals 25. Angle E equals angle B, which is 180 minus 25 minus 112, which is 43. X plus 17 equals 43, so x equals 26. With number 8, line PN and line KL are the same at 15. Line PM and line JL are the same at 22. Line MN and line JK, one is 32, the other is 4y plus 12. So if 32 equals 4y plus 12, and I subtract 12 from both sides, I get y equals 5. And pause here, please, and do elaborate numbers 9, 10, and 11. Number 9 is yes, because of corresponding parts of congruent triangles are congruent. Number 10, if the 2 figures are congruent, you can map one onto the other with rigid motions. Each part will line up with a congruent part. If the parts are not congruent, the figures will not map. And number 11, triangle PQR is congruent to triangle STU because of corresponding parts of congruent triangles are congruent. Your homework is numbers 1 through 24 all. Let me know if you have any questions, and I will see you next time.